Start by including primitives cube h, declare a shared pointer to a cube, a vector for the camera position with the coordinates 0, 0, and 5.5, a vector for the camera direction with the coordinates 0, 0, 1, and a vector with the coordinates 0, 1, 0. Go to app.cpp, in run, add cube destroy to the destroy lambda function. After set render targets, create a view matrix using XML matrix look to RH, passing the camera position, its direction, and the app vector. Create a view projection matrix, multiplying the view matrix for the renderer's perspective matrix. Call to cube update constants buffer, passing the back buffer index and the view projection matrix. Call to cube render, passing the command list and the back buffer index. In app set window, after reset commands, create a cube using std make share. Call the cube initialize, passing the number of frames in the back buffer, the Direct12 device, and the command list. And after close commands and flush, call to cube destroy upload resources. Open renderer H and declare a FOV of 70 degrees. Declare a perspective matrix. And in render update viewport perspective, build it by using XM matrix perspective FOV RH, passing the FOV, the aspect ratio, a near plane of 0.01 and 140 far plane. In device utils, declare a function named update buffer resource, to which pass the device, a command list, a reference to a destination resource, a reference to an intermediate resource, the number of elements, the size of the elements, and a data void pointer. And use the refactoring to create the definition of this function. Define buffer size as the multiplication of the number of elements to the size of the elements. Create a destination resource using device create commit resource, passing a pointer to a heap property of type heap type default, heap flag none, a pointer to a resource desk buffer, passing the size of the buffer, the resource state copy desk, null pointer, and the IID PPV args of destination resource pointer. Name the destination resource. If buffer data is not null, call device create committed resource with heap type upload none as flag, resource desk buffer with the size of the buffer, the state generic read, null pointer, and the IID PPV args of the intermediate resource. Name the intermediate resource. Create a Direct12 sub-resource data, and to its P data assign the buffer data, its row pitch as buffer size, copy this value to slice pitch. To call update sub-resources, passing the command list, the destination resource, the intermediate resource, 0, 0, 1, and a sub-resource data pointer. Create a new file named vertex formats h, add pragma once, the DirectX namespace, declare vertex post color struct, declare a xmfloat3 for its position and a xmfloat3 for its color. Create a primitives folder and create on it the files cubeh and cubecpp. On qh, add pragma once, include vertex formats h, use the namespace Microsoft WURL, the namespace DirectX, and declare a cube struct. Declare a uint the static context pair with the indices of the cube. Make a type def of vertex post color as vertex type, do a vertex type static context pair for the vertices, and define the vertices of the cube. Add the loading complete flag as false, declare an ID312 resource for the vertex buffer, another one for the upload vertex buffer resource, and a D312 vertex buffer view for the view of the vertex buffer. Do the same for the index buffer using index buffer view. Create an ID312 resource for the constants buffer and an uint8 pointer for mapping the memory to the constants buffer. Declare the constants buffer size, for now to only store a matrix, and the minimum buffer size of 255 bytes. Declare a descriptor heap for the constants buffer and an uint to store the descriptor size, a bytes vector for the vertex shader, other for the pixel shader, an ID312 root signature, an ID312 pipeline state, a float static context pair for the rotation delta of the cubes for each frame, and a float to store the current rotation value of the cube. Declare the initialize function with the number of frames, the Direct3D device, and the command list as arguments. Declare the destroy upload resources and destroy functions. the update constants buffer function, to which pass the index of the current back buffer and the view projection matrix, and the render function, passing the command list and the index of the current back buffer. Define the functions using the Visual Studio refactoring, go to CubeCPP and include PCHH, include DirectX helper and device utils. In initialize, call to update buffer resource, passing the device, the command list, the vertex buffer upload, the number of vertices, the size of a vertex, and the vertices list. Build the vertex buffer view, get buffer location from vertex buffer, get GPU virtual address, size in bytes from the size of the vertices, stride in bytes from the size of vertex type, name the vertex buffer. In the same way, build the index buffer with update buffer resource, passing the device, the command list, index buffer upload, the number of indices, the size of an index, and the indices list. Build the index buffer view getting buffer location from index buffer get GPU virtual address. Its format is R16 uint, size in bytes from the size of the indices, name the index buffer, create a descriptor heap desk, assign the number of frames to num descriptors, its type as CVV, SRV, UAV, shader visible as flags, and build a descriptor using device create descriptor heap, passing a pointer to this descriptor and a pointer to the heap. Name the heap. Now create a descriptor for the constants buffer using resource desk buffer, passing the number of frames and the size of the constant buffer. Create a commit resource with device create commit resource with the upload property of the heaps, the flag none, a pointer to the descriptor of the constant buffer, the state generic read null pointer, and the IID PPV args of the constants buffer pointer. Name the constants buffer, obtain the address on the GPU of the constants buffer with get GPU virtual address. Create a CPU descriptor handle for the constants buffer with the function get CPU descriptor handle for heap start through the heap, and obtain the size of the descriptor using device get descriptor handle increment size, passing the type CVV, SRV, UAV. Iterate each frame of the back buffer, create a constant buffer view desk. For the buffer location, use the GPU address of the constant buffer. For size in bytes, use the size of the constants buffer and create it using device create constants buffer view, passing the view descriptor and the CPU handle. Move the address of the GPU using size in bytes. Move the handle using offset with the descriptor size. Create a CD3x12 range with parameters 00. Call to constants buffer map, passing the argument 0, a read range pointer, and a reinterpret cast of a double void pointer of the mapped constants buffer address. Clean the memory of mapped constants buffer. Create a task for loading the vertex shader from shader, vertex shader, color CSO. Another task for loading the pixel shader from shaders, pixel shaders, color CSO, and a task which loads the pipeline state once the vertex and pixel shaders are done. For that, pass this and the directory device as dependencies. Declare a descriptor range, an array of root parameter with one element. Initialize the descriptor range with the method init, passing the descriptor type CVV, 1 descriptor, and 0 as base register. Initialize the root parameter 0 as a descriptor table, passing 1 as its descriptor range, a pointer to the descriptor range, and the visibility only for the vertex shader. Create the root signature flags, allowing the input assembler from the input layout. Deny the root signature access from the domain, geometry, hull, and pixel shader. Declare a descriptor of the root signature, initialize it with the init method, passing the number of parameters, a pointer to these parameters, 0, a null pointer, and the root signatures flag. For the serialization of the signature, create an ID3 blob for the root signature and another for the serialization errors. Call DD312 serialize root signature, passing a pointer of the root signature descriptor, the version 1 of the root signature, and the result of getAddressOf on both blobs. Call device create root signature with the arguments signature get buffer pointer, signature get buffer size, and the IID PPV args of the root signature. Name the root signature. Create a static const array of input element desk to describe the format of the vertices. create a descriptor for the pipeline state, initialize the input layout with the pointer to the input element disk and the number of elements in the vertices, proot signature as root signature get, the vertex shader as the shader bytecode of the vertex shader, the pixel shader as the shader bytecode of the pixel shader, the rasterizer state as a rasterizer disk in default mode, but define its cool mode as cool mode front, the blend state as a blend disk in default mode, a depth stencil state as a depth stencil disk in default mode, sample mask as uint max, primitive topology type as topology type triangle, num render target as 1, RTB format 0 as R8, G8, B8, A8, unorm, DSB format as D32 float, sample disk count as 1. Create the pipeline state with device create graphics pipeline state, passing a pointer to the pipeline state disk and the IID PPV arcs of the pipeline state. Clear the vertex shader data and the pixel shaders, and assign true to loading complete. In the destroy upload resources function, release the vertex buffer upload and the index buffer upload. In the destroy function, release the vertex buffer, the index buffer, the constants buffer, the CVV heap, the root signature, and the pipeline state. In update constants buffer, if the loading is not done yet, just do nothing. Add the rotations delta, create a world matrix using XM matrix rotation Y, create a world view projection matrix transponding the result of the multiplication of the world to the view projection. Calculate the destination address to copy the matrix using the back buffer index as offset. Copy with memcpi the matrix values. In the render function, if the loading is not yet done, just do nothing. Assign the root signature with command list set graphic root signature. Create an array of descriptor heaps pointers and assign the pointer to the constant buffer view heap. Assign the descriptor heap using command list set descriptor heaps, passing the number of descriptor heaps and the array of pointers to the descriptor heap. Assign the pipeline state with command list set pipeline state. Create a GPU descriptor handle with the CVV heaps get GPU descriptor handle for heap start function, using the index of the back buffer and the size of the constants buffer descriptor to calculate its offset. Call to command list set graphic root descriptor table using 0 as the root parameters index and the GPU descriptor handle. With command list IA set primitive topology, assign the topology type as triangle list. With command list IA set vertex buffer, start from the first vertex with a single vertex buffer view and passing a pointer to the vertex buffer view. With command list IA set index buffer, pass a pointer to the index buffer view. And call command list draw indexed instance, passing the number of indices, 1 instance, 0 as the first index, 0 as the vertex base, and 0 as the location of the instance. Add a shaders folder to the project, add a vertex shader folder on it, and a pixel shaders folder. Add color HLSL to pixel shaders, and do the same on the vertex shaders. In the vertex shader, start by adding a C buffer to store the worldview projection matrix. Create a vertex shader input struct, and declare a float tree for its position. Add a float tree for its color, then create a pixel shader input struct with a float 4 for the rasterization position and a float 3 for its color. Declare a main function which returns a pixel shader input and gets a vertex shader input as its parameter. Declare the pixel shader input as the output. Calculate the rasterization position, multiplying the position vector and 1 for the W component with the worldview projection matrix. Copy the vertex input color and assign these values to the output values of the vertex shader and return the pixel shader input. Copy the pixel shader inputs declaration and paste it into the color pixel shader. Declare a main function which returns a float 4 and gets a pixel shader input as a parameter, and return a float 4 with the RGB color values and 1 as its opacity. Add vertex formats H to the project, add the cubes files to the project, add a shaders filter to the solution. Inside it, add a vertex shaders filter and another filter for the pixel shaders. To this filter, add the color HLSL file from the pixel shaders folder, and also add to the vertex shaders the color HLSL file from the vertex shaders folder. Open the properties of the vertex shader, set its type as a vertex shader, set its shader model as 6.1. In the output options, set the output object as outdir shaders vertex shaders, filename CSO. Open the properties of the pixel shader, set its shader model as 6.1, its type as pixel shader, In the output options, set the output object as audio shaders, pixel shaders, filename CSO. Try to compile the shaders, and if this DXCCX error appears, open the projects folder, go to the folder x64, debug or release depending on the compilation mode, create the shaders folder, inside it create a vertex shader folder and a pixel shaders folder. Try to compile again. Fix this missing semicolon on CubeH. Replace this X4C in Cube initialize. Compile the project. Execute it. The result is a spinning cube where each vertex has a color.